Howdy. Today, Ben Davidson had a very interesting paper to offer. Transient response of polar cusp ionosphere to an interplanetary shock. And I was thinking that, yes, polar cusps. I have been pondering about these for some time since I found a certain picture which I will show you in a moment. Abstract, interplanetary. IP shock-driven sudden compression of the Earth's magnetosphere produces electromagnetic disturbances in the polar ionosphere. Disturbances. Several studies have examined the effects of interplanetary shock on magnetosphere-ionosphere coupling systems using all-sky cameras and radars. In this study, we examine the responses and drivers of the polar ionosphere following an IP shock compression on June 16, 2012. We observe the vertical drift and concurrent horizontal motion of the plasma. The vertical drift. Something very important to remember. We can read a bit on, but maybe we make it to the abstract. But let's see. I haven't read the whole paper yet. I'm too excited. I have too much other things to do. But anyway, observe the vertical drift and concurrent horizontal motion of the plasma. Observations from Digisonde located at Antarctic Songsang Station showed an ionospheric thick E region ionization and associated vertical downward plasma motion at F region. In addition, horizontal ionosphere convection reversals were observed on the superdual auroral radar network ZHO and McMurdo radar observations. McMurdo seems to be also in the Antarctic, I think. Findings suggest that the transient convective reversal breaks the original shear equilibrium. It is expected that the IP shock-induced electric field triggers an enhanced velocity shear mapping to the E region. The horizontal motion of the plasma was attributed to only the dusk-to-dawn electric field that existed during the preliminary phase of sudden impulse. We also found that ionosphere convection reversals were driven by a downward field-aligned current. The results of these observations reveal, for the first time, the immediate and direct cusp ionosphere response to the IP shock, which is critical for understanding the global response of the magnetosphere following an abrupt change in interplanetary magnetic field and solar wind conditions. So, downward field-aligned current. For those who remember, or watch my videos, or just know it, it doesn't matter where or how, it's enough if you know about that. The Aboriginals from Australia, they associate Aurora display in the skies, northern lights or southern lights, Aurora borealis in the north, Aurora australis in the south. They associate them in their myths and tellings from the past with a river of fire from the sky, death and destruction. Here in Finland, come check out the nice northern lights. Oh, very beautiful. Yeah. Until they are not so beautiful anymore. Because I think the Aboriginals in Australia and their tales are telling about the aurora touching the ground. And they are very hot. 2000 degrees more. The Steve phenomena. Do we still have the news? Wait quickly. I have to check something out. Space weather. Yeah, it has updated. So no, we have to go at least one day back, maybe two. 25th view. Severe geomagnetic storm. Here we have Steve. And it says, "This was the first time I have seen a severe geomagnetic storm here in Spokane," says Burchell. "It was all very profound and a surreal experience. Steve, strong thermal emission velocity enhancement. Looks like an aurora, but it is not. The phenomena is caused by hot 3000 degrees Celsius. In order to melt quartz, you need about 1600 degrees. So this is more than enough to melt quartz. Ribbons of gas flowing through Earth's magnetosphere at speeds exceeding 6 kilometers per second, 13,000 miles per hour. These ribbons appear during strong geomagnetic storms, revealing themselves by their soft purple glow. Steve also appeared over South Dakota, Washington State, Idaho again, Montana again, and Scotland. Yeah. Scotland just once marked. But anyway, back to the article. This is just the abstract, which is fortunately rather short. So, what I found very interesting today is, when I read this the first time, it was the vertical drift. In other words, it goes up and down if there is a shock wave or stuff going on. And since Earth magnetics are weakening, it might come even further down. So, now I wanted to show you this picture I have been showing you many times. This one. I found that because I was noticing some repetitive weather pattern. And I was learning about the electric universe and stuff like that. So I gave it a go and searched for something which could in a way relate to the weather, and I found this map here. It's a surface conductivity anomaly from the European Planet Observing System, EPOS. And I made the drawings, which are really sketchy. But anyway, the plasma rocks and the copper mine is marked here in this green circle, and the Outokumpu copper mine is in the other green circle. So they are basically side by side. And I made once a video about this because I found another picture which I found very interesting, which has very much similarities with this picture here. And I took contact to the EPOS, European Planet Observing System. There is a Finnish guy working there, or was, which was part of making this map here. And I was very excited. Yeah, I found something. They never responded, but they took the whole picture and all the data and information about it down from the internet. It's not available anymore since then, which is a pity, because it could be that these kind of things play a bigger and bigger role as we go further in time. Earth's magnetosphere is weakening, the sun activity is increasing. The vertical drift. It might be very important. Like I mentioned the Aborigines just before. So that's the same picture once again, with different marks. And here on the right we have another picture. And I somehow try to connect the things which I think are very similar, which are these parts. Maybe I have to use another color. Let's use green. There is no green in the picture yet. This part might be this part. This part might be this part. And of course the one in the middle is the one in the middle. And the thing on the right is the cusp reconnection from the Birkeland current of our Earth, from the magnetosphere. So now I've been searching quite a long time for a picture of the polar cusps in my own pictures until I figured out I could actually Google it. So I have no idea where I have been just a few seconds ago since I put pause on my very professional recording equipment, which is just a phone. So now I've been Googling something. So that's the polar cusp here, this region. And Earth is down here. And also to note is that it's really stupid that this picture doesn't fit as a whole on the screen. Yeah, now it's probably visible. And they're talking about, now I changed the color again, they're talking about the vertical movement of that. And I think it's very possible that it goes down here, touches the surface of the Earth. In other words, as I proposed already once in the past, I think, maybe this surface conductivity anomaly imprint in Earth's crust is a sign that there has been once a pole, either south or north pole. I don't know how long it has been there, maybe a few seconds, maybe thousands of years, who knows. But I think this surface conductivity anomaly could be proof of this being once the center of a pole. Would be very interesting. There's like quite much evidence about these kind of things, that they really have an effect, or these things are marks from the past. And as I recently once showed, that we had this aurora in August, which was, I was really surprised that there was anything, because it turned out next day that it was a surprise geomagnetic storm. This event was not in the forecast, so the resulting auroras came as a surprise. That's from the same page we watched earlier something. And these pictures are taken here. At the interface of the polarities, plus and minus, north and south, and the direction of the aurora display, which was, let me use a very interesting word, predominantly this direction. It wasn't this way, it was this way. Aligns with the interface of the polarities of the surface conductivity anomaly. Maybe I have to check out if there's some stories in the Kalevala or some other old Finnish tradition about the auroras touching the ground. Maybe there is something. Maybe it hasn't been found yet because no one thought about that. But let's see if I have time for that. Maybe I stumble across it. I don't know. But anyway, this is just what I think. This is what the experts just found some days ago, or published some days ago. The vertical drift and concurrent horizontal motion of the plasma. Very interesting. Thanks. Bye.